which we tend to call it unforced vibration also. So if you read some textbook, they call it free vibration, okay, or unforced. Then hopefully we can do some spring in parallel and series configuration. If I can't do it, we'll do it tomorrow. Again, reminder on Thursday, every Thursday, 9:30 a.m. lecture. Are we clear? Okay, some of you are not aware of it. But before we go into an undamped free vibration, how many of you are very comfortable in constructing free body diagrams and determine reaction forces? How many of you are comfortable? How many of you are not comfortable? Okay, so only some of you are comfortable. Okay, so let's talk about free body diagrams first, okay? Because later on we have to construct quite a bit of free body diagram, okay? So if we have a beam, and the beam on one side is pinned, and on the other side is a what? Roller. So point A and point B. So one side is pinned, the other side is on a roller. And if we have a force coming down as P, okay, our free body diagram tend to look like this. Okay, so we have a load coming down as P, and if we have a configuration, this is our X and this is our Y. We know that over here you have a AY, and over here you have a AX. Now, at point B, what is the reaction force? Yes. Why? I'm not saying it's wrong. Why? At point B, what's the reaction force again? Y, AY, right? But why not downwards? Upwards is correct, but why not downwards? How can you prove it to me that it's not downwards? Yes. Very English. Nothing wrong with that. Why? This is correct. But why not downwards? My daughter, 8 years old, asked me a question. Yes. It's really opposing. My daughter, 8 years old, asked me, how come when I'm younger, you know what I want, and when I'm older, you cannot figure out? 8 years old. I was having my meal. You know what I did? I was having my favorite meal on that day. I put down my forks and spoon. I have to think 5 minutes to answer her. Anyway, I will not tell you what's the answer yet. All you need to do is now focus on moment. Yes or no? Right? So when you focus on moment, the answer is clear. So if I were to have a pin on point A, P will generate a clockwise or anti-clockwise moment. Anyone? Clockwise. If By is downwards, what will happen to the moment? Going clockwise or anti-clockwise? Clockwise. What will happen to the structure? It somehow will want to what? Rotate. Are we clear? That is why By have to be what? Upwards, so you will generate an anti-clockwise what? Moment. For this reason only. Always apply this principle when constructing your what? Free body what? diagram. If not, it gets really, really frustrating that you are not sure whether is it positive or what? Negative. Are we clear? So switch to what? Moment analysis. Okay, number one. Next thing that I want to teach, I think you guys know about it, is just a recall. Okay, so I'm here to now, the next thing that we want to do is we are going to construct a multi-body free body diagram. Okay. So multi-body means what? There's more than one body in this case. Okay. So now, what if now, okay, you'll probably see this later in 2P. You'll later see this in 3A, but I want you all to know all this first. Okay. If now we have a member AB that's riding on horizontal, and then we have another member attached to a pin at point B. I'm still nervous. Unbelievable. And over here, we have a pin. Okay. And then we have a load coming down as By. Member AB is going through tension or compression. I have someone putting his hand. Sorry, I did not see you earlier. So this has to go to By, has to go upwards because it has to generate a counter moment. Right? Because P is generating a what? A rotation about what? A rotation that is in a clockwise orientation. Right? By has to go upwards to counter that what? Moment. Okay. Now, coming back to multi-body. BC is under tension or compression. AB is under tension or compression. Yes. CB is under tension, tensile. And AB? AB is under compression. What rule do you apply? You cannot don't know. Okay, what rule do we apply? How many of you agree? What rule do you apply then? Okay. So you have a sort of reasoning. How about the rest? Okay. Okay. It's just the second week. I want you to listen to these rules and apply these rules seriously. Okay. Do you all know the term expert witness? Okay. I was the expert witness for 4 times per hour. The first time I was expert witness was in 2012. Per hour was $150. The last time I was expert witness was last year, August. You want to guess the rate? $480 an hour. When someone pay you $480 per hour, you have to be really, really solid on this. You cannot guess the rate. I want you to earn $480 an hour. Are we clear? Okay. So on that week, I earned $15,000. I want you to have that message. Okay. Right. What is the rule? So this is called multi-body. In a multi-body, what will happen is you have to relate 2 body reaction forces. And all you need to remember is Newton's third law. Okay, Newton's third law. And all of you know Newton's third law. Okay. So this structure on its own, let's say this is, we are going to apply static analysis. Okay, we are going to, so over here, all of us know there is a defined cross-sectional area, A, B, C. We have a Young's modulus of BC, and we have a length of BC. Okay. Likewise, over here, you have a cross-sectional area of AB, you have a Young's modulus of AB, and you have a length of what? AB. Okay. The next thing that we're going to do is we are going to apply method of joints. Have you heard this before? Yes? No? Maybe? Okay, we're going to apply, thank you. We're going to, oh shit. Oh yes, sorry. We are going to apply method of joints, and then we are going to apply thrust analysis. Okay. Thrust analysis define that the load is acting along the neutral axis. Okay, you will learn this later, but don't worry, it's just a definition over there. So method of joints is we are going to focus at point B. Okay, point B is the point of focus, and we know that over here we have a load known as what? By. I'm going to change the color of my ink. We are going to draw a green line. That line represents our neutral axis on AB, and then our neutral axis of, BC, and this is for AB. So this line over here is for our BC, and this line over here is our AB. Okay. And then I'm going to sketch our member, okay, BC. So this is BC. This is AB. The green line represents the reaction force of the members. Okay, the green line also represents the reaction forces. Okay, the green line also represents the reaction force direction. Sorry. Okay. And then we are going to call this our X, and then we're going to call this our Y. Okay. Now, which member can take a vertical load? AB or BC? BC, yes or no? Only BC can take vertical load. Why BC can take a vertical load? Because remember, BC will have two components. Yes or no? BC will have two components because BC will have a horizontal component, and also, so we call it BCX. And we also have what? BCY. Okay, so I want all of us to focus on BCY first. Okay, why focus on BCY? Anyone? Because point B on its own now, that dot will tend to what? Drop. Yes or no? Right? So how to prevent the ball from, or that point B from dropping is we have to have a what? A counter. Right? We have to have a what? Counter. Newton, which law? Third law. Action equal to reaction, same in magnitude, different in what? Direction. So we fix part of the problem. But what's the problem when we have BCY? you're going to have a what? PCX. When you married to a woman, or when you married to a girl, or when you married to a guy, always remember it comes with the family. Don't say, love, I only love you, but I don't like your mom and dad. Does not work like that. Are we clear? Same ideology. If we have a